Okay, so we are using the QR package, Quantreg package. That's what you are going to use. I've sent them to you already. So what we are going to just do our installation and start to work with the data. So we can start with the R, and I'll explain as we go along. So you can open the QR plus QQR code. If you have not installed this one, you know the process. Install the package is Quantreg, then you and set your working directory. Are you where I am here? Are you here? You should have even let you use the new underscore QQR, but that's fine. That could give better results than the other one. Okay, so Peter, yeah, moving on. So run up to here, up to save estimates. If you have an estimate saved in your working directory, you should have something like this. Okay, let me explain. So let's start from here. So here you want to set up the quantiles. Depending on the size of your data, then you choose how many you want to. So this one, we are saying we are looking at the 5% of the data through to 95% of the data. And we are changing it by, increasing it by 5%. So that will give us 19 different quantiles. So the 95th quantile and the 5th quantile, that's a lot. We have captured at least 95% of the data. So both the large and the small data sets are captured. So that's what it means. Or you can just set up any set of quantiles, depending on the size of your data. Let's say 0.2, 0.2, 0.6, 0.8, and 0.9, whatever you want. But it's better to let them be equally divided. So 0.2, 0.6, maybe 0.9. Doesn't matter. So now here you have indicated that these are the specific quantiles that you want. Here we said 119 quantiles, 5 to 95, increasing by 5. Okay, so when you set that one up, then you come and run the regression. So it says RQ. This is where you are indicating that you are running a quantile regression. So the dependent variable is the GDP and independent variable is EPU, according to these quantiles, which you have as tau. So if you run that, I'll give you the coefficients and we save it into QR, and that's what is here. So you should have this equation and this output. It should be in your working directory if you get to this line. So if you look at it, you see that you have different coefficients for the quantile that we chose. So that's quantile regression for you. It's not OLS anymore. OLS would have done 50% on one side and 50% on the other side. So typically when you do 50% quantiles, that is OLS specifically. So you can just do, say, let's say, I'm typing these ones, later you can look at them. So 0.5. This is OLS. So you can compare, if you run this, you can compare what the differences are. Okay. There's one thing that I want you to, okay, let's before we get there. So you saw the coefficient, you didn't see the significance of the coefficient. So let's run this again, and we'll see whether the coefficients are significant or not. So you can run QR1. So the first one, we only save the coefficients. We didn't save all the other properties. And I want to save the coefficients themselves and all the other properties. So run this one at QR1. Then there's the SE, which is significance level equal to boot, that gives us the p-values. Depending on the data, sometimes you won't get p-values, you just get confidence intervals. Okay, and then we save it as summary and capture it into our working directory. We are lucky we have the p-values. So that's what I'm copying something, watch, paste it, and what I've done, remove intercept. So showing you something. If you run up to here, you should have this. And you see the quantiles, 5% to 1%, 15, all the way to the last one. And now you can tell whether the estimates are significant or not with the p-values. Then we can check if those ones are significant. So KR2 in test file. They seem not to be significant as before, so nothing changes in terms of significance, and that's because of the data. So can always change the data. So let's do one more thing. If you are following me, let's copy this and paste. We are doing multiple regression, so so what I'm doing now is making it a multiple regression. So I just copied the same thing and I added all the independent variables that I added. So you see here, I just added the rest from the data. There are 3 more independent variables, I added them. That's the only difference I've made. So you can change this to 2. Just to get, just so that you don't lose the previous files you have saved. Okay, so do that change. You copy everything, you paste, and then you add all the independent variables to make it multiple. And make sure you subtract the intercept with this -1. Mistake. Okay, so we are in PR. Okay, this is fine. Let me show you PR1. Okay, so if you have these different estimates for the quantiles, and in the test file, you can know the significance of them. So it's this one. If you make the changes I did and you run, you get that. So make the changes until I highlight them for you. So based on what we have said, you can make some sense out of the output. So let's go back to the QR file in Excel. Actually, let's look at the one without intercept. So if you look at this, you are, based on the literature, what you should do is determine which part is the extreme conditions. So you can say maybe from 80 to 25 is extreme to the right. Then maybe up to the 20th is extreme to the left. And then the middle is the normal market conditions. Okay. So what we are looking at is the type of relationship. So it is GDP against EPU. EPU is the independent variable. So you see the far extreme market condition, that's when markets are not doing well. There's a negative relationship between EPU and GDP. Now, this negative relationship is happening at an extreme market condition. So according to the Lucy and Bauer, because this is extreme market conditions and it's also negative, you can use EPU as a hedge for GDP, as a safe haven for GDP. So it's not just negative, it is negative in extreme market conditions. So the two can behave as hedges, safe havens for each other. Okay. Now, when you come to the upper part of the distribution, it's also negative. So that can be a diversifier for each other. So GDP and EPU can diversify for each other, negative relationship. And these relationships are also very small and they are almost the same. Actually, they are the same, which is very strange. Then, if you come to the middle of the distribution, it's also negative and very small. So you can use them as a hedge for negative. So that's how you should explain the coefficients. They shouldn't be the same as they are here now. Maybe something's wrong somewhere or it's because of the data. And this is, I think, monthly data, so the dynamics may not be very clear. So that's how you explain this. So you can infer hedge, diversification, and safe haven based on the Lucy and Bauer definitions. I'll put them at the end of the slides. Okay. So this is how you interpret this data. And it is, I mean, under the assumption that these coefficients are significant. Okay. In fact, they are, under the assumption that these coefficients are significant. You do the same thing with the multiple. The multiple, where is it? PR2. At least for this one, they are not the same. So the same implications. So these are negatives all the way here. So they can be safe havens. But if you look at inflation and GDP at 15 quantile, it's a positive relationship, so it cannot be a safe haven. But it's a small magnitude, so it can be a diversifier. Okay. If you look at the 20th quantile, inflation and GDP, positive, very big, cannot be, that's like 22%. It cannot be a safe haven, and it doesn't look like it can even be a hedge. So look at the middle, you see both positive and negative there. So you are juggling between hedge and diversification. Let's go to the upper part. You can diversify here with the negative ones, the positive ones. Unless they are very, very small, you cannot diversify. For these big ones, there's no reason to put them together in one portfolio because there's no benefit from risk reduction. So that's how you interpret this. Okay. So then we can do the quantile on quantile. So here we are saying we add the QQR function. So quantile on quantile regression. Depending on how many quantiles you want, you set this one up. So this is the 19. So as before, 0.5 jumps. So you set everything up here. So that this will give you maximum 19 by 19, the QQR function. After that, you are going to create a matrix of a 19 by 19 row and column so that you feed the data into it. Then you come here. This is where you are running the regression itself. So you see here, I put GDP and EPU. See where I've highlighted, you can make that change. GDP and EPU, those are the X and the Y's in that order. So GDP is Y, EPU is X. So 0.05 across the quantiles. Then we are going to loop from 1 to 19. So we can run this. Shouldn't have any errors. And depending on how big the file is and how fast your PC is, this can take a little while. It's done. Then you can save it. Okay. So get to this point. Let's see. Okay, so the values are the same over all the 19 quantiles. Remember, you can also do this for the multiple regression. So you just need to add the independent variables like that. Okay, so the 19 by 19, they're all the same. If you take this, it's not the same, which is not very useful. And because of the function. So new underscore QQR. The function in there gives you different values across the quantiles. And it's the same thing. So you just run that code. You should get different quantiles. That's the quantile on quantile. Now, when you're explaining, you are taking both the quantile of the dependent variable and the quantile of the independent variable. That's a non-parametric equation. So you have the two coefficients and you have the two quantiles. So one coefficient, the H, and the two quantiles, that's a 3D. If you look at our papers, that's how we do it. Let me open one of them for you to see. So if you look at this, so this were the early days, right? So if you look at this, these are the quantile regressions here. Quantile regression, then I did OLS. See at the bottom is OLS to compare. Okay. So, and this is frequency domain. So with different, see IMF1, IMF2, all the way like that. You see the 19 quantiles there. Then, because the quantile on quantile is non-parametric, like you have seen, this is just Excel plot. I take the 19 coefficients of the quantile regression, and I take the 19 coefficients of the quantile on quantile regressions, and I plot them just to see the behavior. And you see how the patterns are very similar. And this is a confirmation of the significance of the estimates of the quantile on quantile regression. Because for the quantile regression, I can know with my p-values. For the QQR, I can't. So I just compare them to the QR, and you see how the patterns are the same. This one, they're almost indistinguishable, the same way as this one and as this. So that's how you compare the significance of your quantile and quantile regressions with quantile regression, or their estimates of each other. This one is plotted from MATLAB, so we can leave it for now. But they are not very nice, like new papers. Where are some of the new papers? Let's see. Because of the function that we use, which is giving us the same estimates for the quantile regression, the QQR. Let's see which of our papers has Bosman. Show you another one where, okay, yeah, let me show you this one. If you look at this, for example, you realize that the plots are different. So in that one, the coefficients are not the same, like you saw. So this is what gives you that. If you open the QR, new_QR script, which I've given you already. So what you should do, this is like your practice. Instead of running this script, you do the same thing, but this time you should run this script. You should run the quantile, this one, the new. That gives you estimates that are not the same for the QQR. And if you do that, in the future, if you want to plot a 19 by 19 matrix in MATLAB, if you want to do that later, I can give you the codes. But if you have MATLAB installed on your PC, then you should use the QQR, the new QQR code. So do that one as practice. If you have any issues, then you can send me an email. I'll address them for you. So do exactly the same things we have done today with the new QQR codes, and you see how the results are different. And because of the functions, the differences in the functions that we use. Okay, so that's it for QQR. It's a simple method, but it captures a lot of dynamics in the market. Okay, and I think that is enough to end the session. So, Farouk, if you look at this code, look at the data we are feeding to them. These are IMF1, IMF, and all of that. So it is frequency domain in quantile regression. And so when you do your decompositions, just bring them here. So now you are solving two problems. You are solving a symmetry problem, and you are solving frequency domain problem. So the frequency domain addresses the heterogeneous market hypothesis, and asymmetry also addresses, let's say, the adaptive market hypothesis. Asymmetry, fat tails, irrationality in the market, all of that's captured. So you decompose, you bring them and do QQR or QR. And going forward, try to use this code because the results are more desirable than the other one, especially for the QQR part.